Today we're going to talk about a very powerful aspect of object-oriented programming, and that is the idea of inheritance. Preface the actual example using inheritance. I'm going to talk a little bit about maybe a hypothetical system that we could be. Let's say we are creating a application for the zoo, right? It's going to keep track of the different animals that live in the zoo. And animals can be broken down into subcategories. For example, there are birds, mammals, reptiles. There are, well, let's even go back further. First of all, there's vertebrates and invertebrates. Vertebrates have a backbone and invertebrates don't. So what would be things that would be in the vertebrate category? Well, there would be mammals, fish, reptiles, amphibians, and so on. We could take this and divide it even further if we wanted to. Under birds, there are eagles, robins, sparrows, and a bunch more if we choose to do that. Under mammals, there are dogs, cats, horses, etc. Now, there's some things,
You forgot to turn the board on yet.
there's some things that all animals have in common. All animals have a birthday, right? Every animal that exists, if we were categorizing animals in the zoo, they all have birthdays. Now, the way their birth might be different. For a bird, it's when the egg hatches, when a mammal is born live, and so on. But everything, even under invertebrates, even spiders, jellyfish, they all have birthdays. So that's something that's common that every animal has. Every animal eats something. All right. Now it's different for each animal, right? But every animal eats something. All right. Now, that's true of every animal. So if it's true of every animal, then it's true for the vertebrates, and the invertebrates. And it's true for spiders and jellyfish. And it's true under the vertebrates for birds and eagles and so on. In other words, if we're talking about in object-oriented terms, in terms of programming, all animals have certain attributes. And every subcategory of animal also has those attributes. All animals have certain behaviors. Like, for example, every animal eats. Every animal dies. And so on down the line. So, these are characteristics of animals. They are also characteristics of all the subcategories underneath animals. So these attributes and behaviors exist for vertebrates, for birds, for eagles, all the way down to the invertebrates, spiders, and jellyfish. However, certain animals do things that other animals don't. For example, spin a web. Only, to my knowledge, only spiders do that. All right. So that would be something that a spider can do that other animals can't. Dogs catch frisbees. I don't know if it's true, but I've never seen any other animal trained to catch a frisbee. So we'll say that dogs are the only ones that can do that, whether it's accurate or not. When we have something, these subcategories are said to inherit the properties and methods of the category above them on the list. So for example, mammals all have live births. So you're not born as an egg or anything like that. You're born alive. It means that dogs and cats, because it's the category and the subcategory gets everything that the category contains. Vertebrates have backbones. So how many vertebrates? I think I'm using this wrong. I think it should be. So how many vertebrates? We know that every vertebrate fits in that category and has a backbone and has a certain number of vertebrates, and that number depends on the specific animal. Humans have, I don't know how many, but all humans, I believe, have the same number of vertebrates. So when we're doing this, and what this relates to in programming is we can put things in subcategories of other categories. Now, and we can do that based on the ISA test. So a dog is a mammal, right? So we can put a dog as a subcategory of mammal. A mammal is a vertebrate. So we can put mammal as a subcategory of vertebrate. finally, a vertebrate is an animal, so we can put vertebrates as a subcategory of animal. That's what we do in inheritance. We define subcategories of classes that we have in the system. So for example, I didn't create it this way, but let's imagine our pizza parlor example, if we were going to expand it. We could have products as a class. And we could have pizza inherit from products, and we could have sandwiches inherit from products. Pizzas have a crust, all right, and the kind of cheese and the toppings. But all products have a price, a name, a description, and number of calories, let's say. So if I define at the top of my list a product class that has a price, has a description, has number of calories. If I define a subcategory underneath that, for example, pizza, it automatically gets the properties that are defined in the superclass. By the way, pizza is said to be a subclass of product. Product is said to be the superclass of pizza. So everything that's a subclass gets everything that's defined on the superclass. And by everything, I mean functions, methods, and attributes. Plus, it can have some more. Like not every product has a crust, right? So that's an attribute that pizzas have. Not every subcategory has toppings, especially if you consider maybe one of the categories of the products that the pizza parlor sells is pop. You can buy a can or bottle of pop from the pizza place. Well, that doesn't have a crust. That doesn't have toppings. You can't order a Pepsi with pepperoni on top of it. All right. But yet every subcategory underneath product has a price, has a description, and has a number of calories. We could have sandwiches defined. And maybe the type of bread. And condiments used on the sandwich could be attributes. Now, sandwiches are a subcategory of products. Therefore, every sandwich also has a price, a description, and number of calories. The idea is like this. When we define a subclass and a superclass, we define the stuff that is in common in the superclass, and then we inherit the subclass from the superclass. So if we were doing this, I'm going to write pseudocode, which is not real code. If I have a class product, it might have a string of a description. It might have an int of calories. It might have a double for price. If I have pizza, which inherits from product, and the Java term for inheriting from is extends, I don't have to redefine the string description, the number of calories, and the price as attributes of pizza. By virtue of the pizza class extending products, it automatically gets those attributes, along with any methods. So for example, there might be a set price method that accepts an argument. There might be a get price method in the product. I only have to put that in the pizza if the price is calculated a different way than for a standard product. So pizzas aren't priced the same way that bottles of pop are, right? Bottles of pop simply have a price. With pizzas, the price is calculated based on the size and the kind of crust and what the toppings are. So pizzas would have a different get price method than the standard method of just having a price defined for it. Again, you can tell that something belongs as a subclass if it has an ISA test, if it passes the ISA test. So for example, a pizza is a product. Yes, that's correct. A pizza is a product that this restaurant sells. Pop is a product that the restaurant sells. Sandwiches are a product that the restaurant sells. Birds are vertebrates. Vertebrates are animals. German Shepherd is a dog. Dogs are mammals. Mammals are vertebrates. Vertebrates are animals. So we do the ISA test. If we can say that A is a, or is an example of, or is a type of B, then A is said to be a subclass of B. So if I had tax, is tax a product? Not really. So I couldn't make a tax class that was inherits from product, because a tax isn't a product, right? A tip isn't really a product. It's an extra payment that you make because of the service that you get. All right. So the idea here is you define things that all members of that class have in common, and then a subclass gets everything that you've defined on that level. Let's go out and see if there's any good inheritance examples on the web. All right, here's an example. A little different than mine. But it has maybe a little bit more stuff. It has a class defined as pet animal. And all pet animals have a name and have a eat method. And in this case, the eat method simply outputs that I can eat. Now, if we create a method, or if we create a class dog that extends pet animal, it gets these things automatically. You don't have to redefine them in the dog class. So you don't have to put string name as an attribute in the dog class. It already gets it from the superclass, from the class that it inherits from. And you don't have to put the eat attribute or eat method in there, because it automatically gets the eat attribute. And they show this example here that I can create a new dog object. I can give it a name. I can display it, and I can called the eat method. So I can do this, and this is good to do and okay to do because a dog is an example of a pet animal, or a dog is a pet animal, or a dog is a type of pet animal. So that's valid. Now, bicycle, on the other hand, is not an example of a pet animal. All right, bicycle, therefore, would not inherit from pet animal. Now let's look at an example in our pizza example that we've been going over the past few times. Hopefully this example will make concrete some of the ideas that I've been talking about. What we have here is we have I'm going to open up the order. And I've added a new class to this called delivery order. Now, is a delivery order an order? Yes, it is. It's just a certain kind of order. Therefore, I can inherit delivery order from order. So under order, I have these attributes. I have a protected attribute string and for name and for phone. Protected means is it can be accessed in itself or any class that inherits from it. So these used to be private in our previous examples. I changed those to protected. Because every order has a name associated with it. Every order has a phone number associated with it. And every order has a list of pizzas. All right. We have our constructors. We can set the name, set the phone, get the phone. We can set name, set phone, get phone, add a pizza. We can calculate the bake time, and we can calculate the price. Now, what is the difference between a delivery order and a regular order? Let's say if you're picking up a pizza versus you're ordering it for delivery. There's probably two things that are different. Number one, if they're delivering it, they need your address. So if I'm calling and I'm going to pick up order from Domino's, I don't have to give my address. I just have to give my phone number, like for identification reasons. So yes, every order, no matter what kind, is going to have a name and a phone number associated with it. And it's going to have a list of pizzas. A delivery order will also have a name and phone number associated with it, along with a list of pizzas, but it will also have an address, city, state, and zip, because with a delivery order, you need to know where to take it. So delivery order has extra attributes. Notice we don't have to define, again, phone number and name, because this extends order. And if it's defined in order, this class also gets those attributes. So anything in terms of functions and attributes that are defined in the superclass, the subclass gets them. We're going to ignore constructors for a minute because constructors complicate things just a little bit. But we're going to ignore the constructor for a minute. Notice I don't need set phone, get phone. Why? Because the order class has set phone and get phone. And this inherits from that. Therefore, this class also gets the set phone and get phone method. We do, however, need set address, get address, set city, get city. set zip, get zip. We need those because those are defined in the delivery order. So the delivery order, because it extends order, has everything that an order has, plus it has some extra stuff too. And in this case, the extra stuff are these extra attributes and these extra methods. Now, the delivery time is something that a regular order doesn't have, right? Regular order doesn't have a delivery time because it's not being delivered. However, this is a new function that a delivery order has that is not contained in the order class. That is to calculate delivery time. In our case, we're simply taking and saying the delivery time is it will be delivered 30 minutes after it's finished baking. So if the bake time for the order is 16 minutes, then it will be delivered within 46 minutes, 30 minutes plus the bake time. Now, bake time, calculate bake time, is nowhere in the delivery order class, but it is defined in the order class. Calculate bake time. So the delivery order gets that automatically. Now, delivery orders, let's say in this example that there's a $5 delivery fee. All right. We can do this and call the superclass method to calculate the price of a regular order and add 5 to it, and that's the price of a delivery order. Now notice in this case, this function is the same as this function. I thought you said that this class, though, gets everything defined in this class. It does, but in some cases, we want to override that. All right. In other words, delivery orders, the price of delivery orders are calculated in a different way than the price of regular orders. In fact, it's the price of a regular order, which is what this does, calls on the superclass, the calculate price method, and adds 5 to it, and then that's the price of the order. So you do not have to redefine the attributes in the subclass. You can add attributes, though, and you can add new methods. And you can override a method that's in the superclass simply by putting the method in and have the different programming logic for this. So let's look at how we're doing this with the test class. Make some changes here. I have 4 pizzas that I create, and I'm creating 2 orders. One is a regular order. One is a delivery order. Delivery orders have their own constructor, and that's one thing that we said we left aside for a minute here, and we'll come back to that. Can I add a pizza to a delivery order? I absolutely can. Is there an add pizza method in the delivery order class? No, there isn't, because that was defined in the order class. And there's nothing different about adding a pizza to a delivery order than adding a pizza to a regular order. So I don't override that method. This delivery order gets this add pizza method to it, so I can call that method. This will give us the cost of the order, the bake time, and when it will be delivered. Let's compile this and run it and see what results we get. Okay, there's all our classes. So I can compile them all. And I can run them. So my first pizza is small, thick, doesn't have pepperoni. Its price is $9 and it takes 16 minutes to bake it. This is large, thin, does not have pepperoni. Its price is $12 and it takes 10 minutes to bake it. The first pizza, the next pizza, the third pizza, the first one of the delivery order, is also small, thick, and false, so it has the same numbers, and likewise the second pizza of the delivery order. Now here's our orders. The pickup order, the cost of the order is $21. The cost of the order here is $26 rather. It's what the cost of the pickup order was plus $5 extra. The bake time of both of them are 16 minutes, which is correct. And the delivery time is 46 minutes because we define the delivery time as being 30 minutes longer than the bake time. So pizza 3 and 4 are clones of pizzas 1 and 2. So the cost of the order, why is the cost of the order different? Because we're calling the method calculate price on the delivery order, which takes the price, if it was a pickup order, and adds the $5 delivery fee. And that's the price, that's the total price of the order. And as you notice with the same pizzas in here, the price of the pickup is $21. The price of the delivery is at $21 plus that extra $5 or $26. Bake time, there is no calculate bake time method in the delivery order. Therefore, delivery orders use the same calculate bake time method as in the superclass. That is order. And finally, calculate delivery time. That's something that doesn't exist in the pickup order. So it is defined in the subclass as a new method, which is calculate delivery time, which takes the bake time and adds 30 minutes to it. Notice what this does. calculate super price. That calls the method on the super class and retakes whatever return value that supplies. So this calculates the price as if this delivery order was a pickup order. And then we add $5 to it, and that's the price that we get. So notice what we code in the subclass. We code what is different between the subclass and the main class. What is different in this case? We have some extra attributes, so we code them. With those extra attributes come these extra methods, so we code them. We have a new function, calculate delivery time. There wasn't a calculate delivery time on the original example because there weren't delivery orders, there were only pickup orders. So this is a new thing. This is what's different than a delivery order from a regular order, is that a delivery order has a delivery time. And we want to be able to calculate that. Finally, we have the calculate price method. Now the superclass has already a calculate price method, but the pricing is done differently for the subclass, and therefore we override the method in the subclass, right? We override the method and put in the new method on how that's done in the subclass. And in this case, that involves calling the superclass, getting the price, and then adding $5 to it. Let's look at constructors, and we're going to spend more time talking about constructors next week and other aspects of this. To create an object, to create a delivery order object, both the constructor of the superclass and the constructor of the subclass have to be called. So we have a method in here, a constructor, because constructors don't inherit. We have a constructor in delivery order that accepts a name, phone number, address, city, state, and zip. Now we have to first call the method in the superclass. And what is the method in the superclass? Well, the method or the constructor in the superclass only accepts 2 arguments. So we call that constructor and pass it the 2 arguments that it needs. Then we go and deal with the rest of the arguments. So 2 things important about constructors right now. And that is that constructors do not inherit. And secondly, that in order to create an object of the subclass, the constructor of the superclass needs to be called first. And how do you call the constructor in the superclass? By doing super, just like we did down here. We're going to go more over constructors next time because there's a lot of aspects to it. There's a lot of ins and outs of creating constructors when you have subclasses and superclasses. We're also going to look at how you declare and how you create objects and what you can do with those. Are there any questions at this point? All right, that's what I had today. You have to do, well, let's look at your homework assignment before we adjourn today, because you're going to have to do something similar with your example. This is the homework assignment for next week.
I was just about to ask.
Okay. You're going to need to create a class called graduate student. And it needs to inherit from your student class. Is that valid? Yes, it is, because a graduate student is a student. The only difference between a student and a graduate student is that the tuition of the graduate student is twice what it would cost for a regular student with the same residency code. So you're going to have to go and create a class that inherits from student, call it graduate student. And then you're going to need to, number one, make sure the constructors work correctly. And we'll talk about that next time. And number two, you're going to need to override the method for calculating tuition. That's really the only thing you have to do here is inherit it and override function. All right, that's all I had for today. If there's no questions, we'll either see you upstairs or we will see you next week.